All right, here we go. So today's lesson is called Factoring Polynomials. Day one, I think this will probably be at least a 2-day thing, which is all good. It should be taken slowly. So factoring polynomials day one. Before we get started on the new stuff, I want to review from yesterday. So yesterday I gave you guys you folks, six questions to practice. 3 of them are multiplying. And then the last 3, 4, 5, and 6 were factoring. So please get out your 6 questions. I hope everyone tried them. And let's do this. Before I just start showing you guys or folks everything, let's hear from you. So someone already mentioned they'd like to go over number 4 and 6, but before we do that, I want to look at 1, 2, and 3. Did anyone do 1, 2, and 3 and they wouldn't mind sharing with the group? Or what about just number 1? Start with number 1. Anybody?
For the first one, I got 3x to the second power plus 21x.
Plus 21x. Perfect. So let's just backtrack quick. 3x times x. That's where 3x to the second power comes from. 2 x's, right? So that's where that second power is showing up from. 3x times 7. 3 times 7 gives the 21. And then, of course, there's that x hanging out along for the ride. And that's where the x is there from. Okay, can anyone else tell me about number 2, please? Anyone try number 2? No one else tried it? Really?
I'll do it.
Hang on, Aaron. Hang on.
Okay.
Thank you.
I got x to the second power plus 50. X plus 50.
Okay, yeah, it was a little shaky, but I think I heard you, Manaya, and I think you're right on point. It was plus 15x plus 50. Is that correct?
Yeah, that's what I got.
Okay, perfect. Thanks, Manaya. So where she got these terms from, x to the second power is x times x. Then she gets x times 10. Put that right here. And she's done multiplying this first x term right here, this guy. So then she moves on to 5. So 5 times x gives her a plus 5x. And these two together are where her 15x came from. And then finally, 5 times 10 is the 50. Any questions or concerns on number 2? Okay. Now, I've heard from Aaron. I've heard from Manaya. Can anyone else help me with number 3, please? Did anyone else try it? Okay, no one else?
I got x to the second power minus 2x minus 8.
Perfect. Was that Janessa?
Delaney.
I'm sorry, Delaney. My screen usually goes yellow and shows who's speaking, but it didn't do that. Delaney, thanks. So you said x to the second power plus what?
Minus 2x minus 8.
Perfect. Perfect, Delaney. Thank you. X times x, of course, gives us that x squared. Then she gets 2x from this multiplication. Okay, and then the x is done. The first x is done. Then we move on to the negative 4. That yields negative 4x, which of course together made her negative 2x for the final answer below. And then negative 4 times 2 gives us the negative 8. Delaney, thank you so much. All right, I've got other folks coming in here. There we go. Okay, folks just joining. We're going over yesterday's homework. Now, I know someone asked about number 4. Did anyone else get a chance to try number 4 and factor that?
I did.
Manaya, go ahead.
I got 5x parentheses 4x plus 3.
5x parentheses.
4x plus 3.
Is that correct, what I have on your?
Yes.
Okay, so thank you for sharing. Let's work this backwards to kind of check the work. Or I think you did a good start by doing 5x, by pulling out that 5x. Oh, wait a second. Let's back up a sec. I'm actually off base here myself. Okay, I see where you got the 5x from. However, the question is, can I pull 5x from both terms? We can take it from the second term, right? Because it is 5x. But can we take a 5 from the very first term?
No.
No. So,
I'm sorry. I gave you my answer that me and my father did together. My bad.
I'm sorry. No, no, go ahead.
My answer was x parentheses x plus 5.
Yes. Okay. Let me put that up here too. X parentheses. And remember, we can read that as x times. So x times x plus 5. Okay, Manaya, thank
Okay.
you. And I'm sorry. I appreciate you taking a risk and putting your answer out there. Misunderstanding, no worries. And I just want everyone to be able to share, no judgment whatsoever. So I'm going to go ahead and just cross this guy out for now. Now, but thank you. I really appreciate it. So can you really quick walk me through how you knew this answer for number 4, the x times x plus 5? Or how did you know that we could take out x, I suppose? Let me ask that.
You're asking me, Josiah?
Oh,
Or are you
yes,
asking
yes, please, Manaya. Sorry. Thank you.
Okay. So first, I know that you could take x out of both of those because there's two x's, and then you can take x again because the x2. So you, yeah, you put the x and then plus 5 because there's only one 5.
Very good. Thank you so much for your explanation. On point. She noticed that each one of the terms has at least one x. So we can take that out. So she factors out the x, put your parentheses, and what's left over? A single x and a plus 5. Any questions, concerns, comments on number 4, please? Okay, would anybody, floor is open, would anyone like to share what they got for number 5?
I got 5x times 4x plus 3.
For sure. And that's the one that you gave me earlier. So it's just yeah, I see where you got that now. Totally. Yeah, and I think you're totally correct, Manaya. We look and see, what can I pull out of 20x squared? What can I pull out of 15x? They each have a single x. So here's where my mind goes with a problem like number 5. We can pull out or divide out. We can pull out for sure an x. So here's my kind of going list. We can pull out x. We can pull out some number maybe, right? 20 is divisible by 4, by 5, or by 2, or by 10. And we can find what it's divisible by using a factor tree. 15 is divisible by 5 and 3. So that's how we know. We can pull out a 5 by making a factor tree. So we can pull out 5x from both terms. So that's where she got that 5x from on the outside. Where'd she get a 4x plus 3? That's what's left over when you divide the original terms by 5x. So here's a way we can do that. Just take the single terms, 20x squared, literally divide it by 5x, and simplify. So do the exponents like we did in Unit 1, and do the whole numbers if there are any. 20 divided by 5 is 4. Boom, 4x. And then the same thing would give us a 3 for the other term. Cancel the x's in this case because it's 1 on top, 1 on the bottom. 15 over 3 is, or 5 is 3. Awesome. Okay, any questions on 6? Actually, someone did mention that right in the way in the beginning. So let's look at 6 together. What can we pull out of this thing and what's left over when we do it? This time, if you look at the exponents on number 6, we've got x to the 6th and then x to the 4th. So what's the most I could take from both of those terms? What's the highest number of x's that could be taken out? Anybody?
4.
4. High five. So I'm just going to put that in my answer as I kind of go here. There's my x to the 4th outside. How about number or coefficient? What's the highest number I can divide from 10 and 5?
5.
5. So I was a little lazy yesterday with my homework problems. I didn't mean for all the 5x's to keep showing up. I must like it. Now let's see what goes in those parentheses. 10x to the 6th, divide that by 5x to the 4th, 2x to the 2nd. And the same thing for our second term, but it looks like we're taking all of it out. So what's going to be left? Just 1. We'll show that here. The whole thing is like same on top and bottom, right? So that's where this 1 comes from. Since it was minus 5x to the 4th, we should see a minus in our answer as well. Okay, there's all of yesterday's homework, basically. Let's get started on factoring polynomials now. Okay. Wish I could make this thing go away. Okay, so I told you yesterday kind of where we're heading in this unit. And frankly, I think it's like the main point of math 2. So it's exciting. Factoring polynomials. Now, my plan for today, I've got 5 examples ready to go. We might not get through all 5, but let's see how far we go. I've broken it down into a 6-step process, okay? Some people appreciate. Now, not everyone might need to use the 6 steps and like write it out and do it that way every time, but some of you might, and I like doing things in steps. So I broke down our process for factoring polynomials into a 6-step thing. We'll see that as we go in the next few minutes. A reminder on what we mean by factoring polynomials. Here's what we mean. When we just did, let me go back quickly to our homework from yesterday. Looking at example 2 and example 3, those start as 2 binomials multiplied together, and then they give us very similar looking answers. So look at number 2 and number 3 again with me. X squared plus a number x plus a number. And then number 3, x squared minus a number x minus a number. Those are very similar. They're both in what we call standard form for a polynomial. For a, technically speaking, it would be a quadratic trinomial. But I'm just trying to warn you the last few days that that's the world we're going to be living in, where polynomials look like this. Some number a, x squared, plus another number, bx, plus c. A, B, and C are coefficients. C is a constant. These are going to be whole numbers mostly. And we want to find out through factoring the polynomial, what did it look like before it got multiplied? X plus some number times x plus some number. And these two missing numbers, they could be negative. So then it would look like x minus x minus. These in A, B, and C could be negative, okay? There's nothing that says they have to be positive. We'll see some examples today with negatives, but this is our goal here. Our practice the last few days was multiplying x plus a number times x plus a number, and we get a polynomial. We also need to know how to go backwards and factor, and that's what today is all about. Before we do the 6 steps and try a factoring problem, I want to quickly examine another multiplication and see how the polynomial is formed. So let's kind of hone in on an example of another multiplying. So let's look at example 1 here. X plus 3 times x plus 10. And then we're going to actually work backwards and factor this back to its current form. But first, let's multiply it. So this is just like the two problems from yesterday's homework. X times x gives us x squared. X times 10 plus 10x. 3 times x plus 3x. And finally, 3 times 10 is plus 30. Finally, we would add together our two middle terms because they're both x terms. So we have x squared plus 13x plus 30. And we're done. So what we just did was multiply the polynomial or the binomials, right? We multiplied these two little x expressions and we get our polynomial at the bottom. Before we start factoring, let's just examine this again. Where did the 13x come from? Can anyone do me a favor? Take a minute, and if you feel comfortable sharing, tell me where that 13 came from. Yes.
Then you get the 13 from the 10x and the 3x.
Very good. And can I just have you keep going a little bit longer with me? Where'd the 10x and 3x come from?
From the original problem, all the way from the top, from the x plus 3 parentheses x plus 10.
Thank you, Braden. Very good. That's what I was hoping you would see. 3 and 10 are right there out in the open, very visible, and it's pretty obvious, I think, at this point, where we get the 10x and the 3x from, right? It was just the multiplying, like Braden said, and we see where the 10 and 3 came from. They're right there, right in the open. And notice that right in the open, right at the beginning, we can kind of see, okay, I'm going to end up adding this term, the 3, and this term, the 10. That's where the 13x comes from eventually at the bottom. How about that 30? That comes from multiplying together the 3 and the 10. So all the ingredients for our polynomial at the bottom are present at the top before we did any multiplying. It's not obvious unless you know what you're looking for, though, right? Unless you know, I'm going to have to account for this A number, this B number, and this C number. Any questions or comments or concerns right now? Again, we haven't really done any factoring, but we're going to start that next. I just wanted to examine where do all the parts come from when we do a multiplication, because that's going to be important for how we work backwards and factor. Our goal now is to start with what I've got at the bottom and work up. This is factoring. So let's do it for this example, and then we'll look at some different ones. Okay, here we go. So we're going to start with the polynomial x squared plus 13x plus 30. This is example 1 continued. And I want to factor this. And I know we already know the answer, but I want to start with one that we know the answer to see the steps in action. Okay, so I've been talking about how we label these coefficients as A, B, and C. Now, we're going to start our examples all today where A is always 1. Later, we'll see problems where A is a different number. But for now, notice that there's no number next to x squared, so our A is 1. Our B is the middle number, 13, and our C is the 30 at the very end, the constant. So we've identified A, B, and C. So step 1 for factoring a polynomial is just identify, write down somewhere, what is A, B, and C. Step 2 is list the factors of A times C. So write this down and then we'll actually do it on the right side. List the factors of A times C. So I'm going to make a list over on the right side of my screen. Multiplies to A times C. What is A times C here? A times C is 30. So I'm going to start with 1 times 30. And then I'm going to kind of move up the chain of numbers. Does 2 go into 30? It does. 2 times 15. Does 3 go into 30? It does. 3 times 10. And just keep going. I want you to make the list as far as you can go. 4 doesn't work because when you divide 30 by 4, you get a decimal. It doesn't go in evenly, so we skip 4. 5 works. 5 times 6 is 30. Now, if you don't know this multiplication and like just from memory or can't do it fast in your head, use a calculator. It's okay. I want all of you using calculators to make these lists of multiples of the factors of A times C. So I've gotten to 5 times 6, and now notice if you keep going, it'll kind of repeat backwards. So 6, well, that's 6 times 5. And there's no 7, there's no 8, there's no 9, but then 10 times 3. So what we're seeing is kind of like at the halfway point, our list will just repeat itself. And at that point, you can stop once you get to where it repeats. Okay, step 3. We're going to use our list in just a second, but step 3 is check which factors that we just made in our list add to B, the middle number. So let me write that down. We're checking which factors of A times C add to B in the middle. So I'm going to make a list next to my original list here, and I'm going to label it. This is just like housekeeping. This is just so that I orderly have a system and know what I'm doing, making this list. We've already made a list of multiplies to A times C. And now I'm going to check to see what these numbers we just made add up to. We want to find the set that adds up to B, which is 13 in this problem. So if we add our A times C numbers, we got 1 plus 30, 31. This one is 17. 3 plus 10 is 13. That's our winner. That one adds to B. You don't have to keep checking after you find the set that worked. So 3 and 10 multiplies to A times C, and it adds to 13, our B. So we identified that. That's like our step 3 is we checked which factors of A times C added up to B. Now step 4. Rewrite the BX term using the factors that we just identified, using the 3 and the 10. And so how should we say that? Rewrite BX using factors from step 3, the ones that we chose. And now here's what that looks like. So back to the center of the screen where we have our actual problem. I'm going to rewrite 13x as plus 10x plus 3x. Because 10 and 3 are the numbers we identified from our list. And this is crucial. We found our correct numbers, 10 and 3, and now we're kind of splitting up our B into 2 parts, 10x plus 3x. Now we're going to do some factoring like we've been doing in the class and the homework the last few days. So step 5 is to factor the first 2 terms and the last 2 terms in like 2 groups. And let me write that down and then I'll show you what I mean. So step 5 is, I'll say first 2 terms and the second two, or the last two terms, the front and the back, the first two terms and the last two. So here's what I mean. I'm going to identify the first two. I'm going to underline those. X squared plus 10x. And then the back two, or the last two terms, are 3x plus 30. So this is kind of like the homework problems from yesterday, but two at a time, right? So I want to factor x squared plus 10x. I can pull a single x from that first set of terms. And then I have to identify what's left over. X plus 10. Any questions so far before I move on, please? Questions, concerns? Okay, well then now we're going to factor the last two terms, which is 3x plus 30. I can pull a 3 from each one of these. I can divide 3 from 3x, and I can divide it from 30. And 3 is the biggest number that I can divide out, so we'll use that. And what's left over here? X plus 10. Now, what do we have? We have x times x plus 10 plus 3 times x plus 10. So if we did this correctly up to this point, you should have matching parentheses. X plus 10, x plus 10. If you don't have matching parentheses, you have to back up and check your work. And maybe you didn't use the two correct terms from the list, 3 and 10. Maybe there was an issue with the factoring. So just double check your work if you don't have matching parentheses. Now, our final step is just to factor out the binomial, factor out the matching parentheses. So let me write that down. Step 6 is to factor out the parentheses, basically. So I can divide out x plus 10 from both of these terms. And what does that look like if we factor out a parentheses? Well, I'm going to pull out the x plus 10. And what's left over from the left and the right after I pull out that x plus 10? I've got x plus 3. And we're done. So we worked backwards with a polynomial. Oops, hang on. Worked backwards with the polynomial to split up the bx into its two smaller components, 10 and 3. Then we factored that 4-termed expression that we have. We pulled out what we could from the first two and the last two. And then finally, we pull out that matching parentheses. We divided it out. We factored it out. And we're left with x plus 10 times x plus 3. Any questions or comments or concerns so far, please?
Wait, so wasn't the first problem like x plus 3 plus times x plus 10?
Correct, but it's still equal to this because remember the order that we multiply numbers doesn't have an effect on the product, like their answer. So whether I wrote it, whether we rearrange this into x plus 3 first times x plus 10, or if we have it this way, it's okay either way. They're basically equal to each other.
Okay.
Any questions on the process, please? We're going to do more. I'm not going to write out all the steps each time. So if you haven't written those out, I want you to take a picture. If you need me to restate it, if you can't read my writing, let's talk about that and hammer out the steps right now, please. The more we do this, the more you're going to just kind of do the steps without thinking about it. But I think to start, it will be healthy and best for everybody if you try to follow the 6-step process. And over time, a month from now, you'll probably be doing this without looking at the 6 steps. You'll just do it from muscle memory. So stick with me. Don't give up. It is confusing, but you can do this, and we will. If there's no questions, let's try another example, a fresh one. Okay, so let's factor. Example 2. Factor x squared plus 13x plus 40. X squared plus 13x plus 40. So step 1 is basically identify and be sure of what is A, B, and C here. So I'm going to write those down. A is 1. Now remember, all of today's problems, A will be 1. Later, we'll see problems where we have different A values. B is 13 again, and C is 40 this time. Step 2 is make our list of factors of A times C. So for now, our A times C is just C, right? It's just 40. So I'm going to make my list of multiplies to 40. And then we'll compare that to the ones that add to the middle number, the B number, 13. So let's see. Numbers that multiply to 40. So start at 1 times 40. Then do 2 if it works. Do 3 if it works. 4 if it works. Just move up the ladder, dividing out whole numbers from 40 until the list starts to repeat. So 2 times 20. 40 divided by 3 doesn't work. It gives us a decimal, so skip it. 4 times 10. 5 times, does 5 work? 40 divided by 5. 5 times 8. 6 does not work. 7 does not work. And then when you get to 8, it's 8 times 5, right? We've already done that one. So we can stop. These first 4 are the only ones that are really going to matter to us. Any questions on that step, please, at all? Making the list of numbers that multiply to 40. No questions. Let's check the sums. We're going to add all these multiples up because we want to pick the group or the set that adds to 13. So you can do this in your head, or you can write it out on a list like I'm doing. 1 plus 40 is 41. Obviously, that's not going to work. 2 plus 20 is 22. 4 and 10 is close. It's 14. And then 5 plus 8 gives us the one we're looking for, 13. 5 plus 8 is 13. Double check. So that's our winner. This is the set we're going to use, 5 and 8, to split up our 13. So we found the set we wanted. That's our step 3. So now we're going to rewrite 13x using 5x and 8x. So in the center of the screen here, you might wonder, does it matter if I do the 5 first or the 8 first? And the answer is no, it doesn't matter. If you had swapped these out and did 8x plus 5x, it'll look a little different how you get there, but we'll both get the same answer in the end. And then our next step is to factor separately the first 2 terms and the last 2 terms. What can I pull from the first 2? Simply x, only an x it looks like. And we're left with x plus 5 again. We've seen that a lot lately. What can I pull from the second 2 terms? I can pull an 8 So I'm going to say plus 8 times what's left, x plus 5. Check that your parentheses match. Awesome. And now the last step is to imagine pulling out, dividing out those parentheses. Remember, remember factoring is undoing distribution. So if you were to pull out x plus 5 from both, you get x plus 5. And you've got to account for what's left over. What's left over is x plus 8. And that's why what's next to our parentheses, the x, and the 8, those are in their own parentheses at the bottom. Because you can think of the x plus 5 as being distributed across x plus 8 if we work backwards here. And we're done. We factored the polynomial, and we know what the two terms were, the two expressions were that multiplied to make it. X plus 5 times x plus 8. Any comments, concerns, questions? Anyone need more time on this screen before we start a new one? Okay. Example 3. Factor x to the second power plus 11x plus 28. Identify A, B, and C. Okay, A is 1 again. There's no number for x squared, no coefficient. B is 11. C is 28. Now make a list of numbers that multiply to make 1 times 28, which is just 28. So multiplies to 28. And then we'll check that against numbers that add to 11. So 1 times 28, 2 times 14. Try 3. I don't think it works. Try it anyways. 28 divided by 3 is 9.3, so we don't use it. 28 divided by 4 is 7. So 4 times 7 makes 28. And I think that's our winner, but let's keep checking. 5 doesn't work. 6 doesn't work. And then we get to 7 times 4. So we're done. So these three are the ones that are contenders. Check 4 plus 7. That's 11. So that means that's the one, the set we'll use. 4 plus, let's write it out here. 4 plus 7 is 11. Yay! So we're going to split up our 11x as 4x and 7x. So continuing below our original problem, we've got x squared plus 4x plus 7x plus 28. Notice that all we've done is found a way to split up 11x in a way that's going to suit us. The whole point of making these lists, numbers that multiply to make that C number, what we're doing is working backwards and finding out what numbers in the parentheses, when I multiply them together, will add to the right thing in the middle and multiply to the correct number on the C number, the 28. That's what we're doing here. It doesn't seem like it, but that's the process that we're going through. Okay, now we factor the first two and the last two. So you ask yourself, what can I pull out of the first two? Again, today's examples may be a little boring because it's the same thing each time. We're just pulling out x. And then you have to figure out what's left inside, x plus 4. Now do the same thing on the right, the last two terms. Here, we can't pull out x, right? They don't each have an x. We can pull out 7, though. And now don't forget to put this plus sign. So it's plus 7, and then what's left over when you pull that 7 out from the last two terms? X plus 4. We have matching parentheses. Awesome. That means we did it right. Pull out the parentheses and show what's left over. X plus 4. That's me pulling out the parentheses, factoring out the parentheses. And then we have to show what's left over. X plus 7. Okay, I expect that people are probably feeling in the middle on this one so far, on this whole process. We have time. I want to do 2 more examples with you to practice. Let's look at number 4. Okay, so again, we're factoring. Now this time we're going to have a negative in the mix. Same process, same 6 steps, but just something to be aware of. So let's factor this. X to the second power plus 2x minus 15. Minus 15. A is 1, B is 2, and C is negative 15. So this time we want to find the numbers that multiply to make a negative 15. And they have to add to a positive 2. Now, when we're doing the multiples, factors of 15, I just write them positively, right? Even if I know the answer is supposed to be negative. Here's what I mean. 1 times 15, 3 times 5. Those both make 15, and I think that's it. If we try to keep going, it'll just repeat at 5 times 3. Now, we have to just keep in mind that one of these numbers is negative, right? Like 1 or the 15 is negative, or the 15 is negative and the 1 is positive. The 3 is negative, the 5 would be positive. Because remember, a negative times a positive is a negative. So that means one of these numbers is negative. So let's try doing our sums. If I had like negative 1 plus 15, that's way too big, right? We're looking for a 2. And if we try it the other, this is going to be 14. And if we try it the other way, 1 minus 15, so I'm switching my negative, this is negative 14. So obviously it's neither of those. So let's try the 3 and the 5. So 3 minus 5 is negative 2. Negative 3 plus 5, I'm switching the negative, is positive 2. That's the mix we want. We want negative 3, positive 5. Negative 3, positive 5. So I like to circle it when I find it. Now we're going to just continue as normal. We're splitting up our 2x as negative 3x plus 5x. And don't forget the negative 15. So it's a little trickier when there's a negative in our polynomial, but it's the same process. And you have to remember, okay, if the 15, if C is negative, that means one of my numbers multiplying to make the 15 had to be negative itself. Okay, now we just continue as normal. Factor the front 2 and the back 2. Here we could pull out x, and what's left is x minus 3. And then here we can pull out a 5. So plus 5, x minus 3. And then we pull out our x minus 3. And what's left? X plus 5. If you wanted to check your work, when you get to the end and you have your two binomials being multiplied together, to check your work, simply multiply everything out. You know, like we've been doing. X times x is x squared. Here, I'll just show it. Check work. So x times x is x squared. X times 5 plus 5x. Negative 3 times x is negative 3x. And then negative 3 times 5 is negative 15. Add together your two middle terms. That'll be plus 2x. And that matches what we started with. That means that we did this right, and this is our answer. All right, it's almost time to go. I'd like to do one more example with you. Any questions or concerns so far? Please, let's talk about it. Okay, let's try number 5. All right, here we're going to factor x squared minus 6x plus 5. Now, there's a negative sign. So that means we have to be on our toes, stay sharp when we're doing our list stuff and when we're splitting up the middle term. The negative 6x, we know we're going to rewrite that as two different things, right? Because that's negative and the 5 is positive, that means there's going to be some funny business going on here. So A is 1, B is negative 6, and C is positive 5. So it multiplies to a positive 5 and adds to a negative 6. Okay, I chose small numbers on purpose here to practice this example. When we make our list for multiples, it's only 1 times 5. 5 is a prime number, so 2 doesn't divide it, 3 doesn't divide it, and 4 doesn't divide it. So it has to be 1 and 5 that we're going to split up. How do we configure the 1 and 5 with negatives and positives so that they add to negative 6? Does anyone see it? Does anyone know how we can make, do we make them both negative? Is just one of them negative? They can't be both positive, can they? Any thoughts on how we make our 1 and 5 as far as negatives go so that they add to a negative 6? Nobody? Okay. So I know that I want to have 1 and 5. I want to add them together, and they have to add up to a negative 6. Well, that means that they're both negative. 1 is negative, and 5 is negative. Negative 1 minus 5, that gives me negative 6. So here's my configuration, negative 1, negative 5, to rewrite negative 6x. So we'll do negative 1x. Remember, we don't have to show the 1 if it's a coefficient for an x, but I'm going to show it anyway so we don't hopefully get confused about where it came from. So I'm just splitting up our b. So all we've done is rewritten our original problem, splitting up b as negative 1x, negative 5x. Now pull out what you can from the first two and the last two. Okay, so we have x times x minus 1. Now over on the for the last two, my first instinct is to pull out 5. They each have a 5, right? If you do that though, here's what we end up with. Something doesn't look right. The first parentheses is x minus 1. The second parentheses is negative x plus 1. So it's not the end of the world. To fix this, you're going to factor out a negative 1, okay? So I'm going to redo this step here by also factoring out negative 1 from the right side. So instead of factoring out a 5, I'm going to factor out negative 5, which is therefore going to change the signs for both of those second terms. So instead of negative x plus 1, it's x minus 1, which is what we wanted it to be. Notice the difference here in these two steps. And let me label this. Pull out negative 5, not 5. Okay, now we're done. Pull out x minus 1, and what's left is x minus 5. Okay, let's try 2 homework problems. Okay. Here's our homework for today. 2 problems, not 6. Factor x to the second plus 12x plus 35. And number 2, factor x to the second minus 2x minus 24. All right, don't leave yet. Let me mark down your attendance. Get these homeworks written down so you can do these today. Please, everybody, don't put off the homework. Don't do it like next week. Do it now so you get the practice, and we all get a chance to learn from each other. Sorry, hang on.